Hello everyone, welcome to the session. I am the CAT mentor at Trident Classes, and in this session I am going to specifically discuss with you what are all the efforts that are required from a student at this point to get to the 99.5 plus percentile. Now this is all but a game of efforts. How much are you willing to put in the efforts? Okay, so specifically I'll be talking about the quantitative abilities. There is a figure right in front of you. It's a right angle triangle, and if I just give you a simple task that you need to prove the triangle ADC, which is a right angle triangle of course, and the triangle BDC, which is again a right angle triangle, all you need to do is just prove these two triangles as, let's say, similar. Okay, so at this point you can possibly pause the video and try to do the thing, whatever you are, whatever is coming to your mind. Now let me tell you why the proving and all that is required. This is where the extra efforts and everything is required. So there is a very interesting property of the altitude to the hypotenuse of a right angle triangle, which says that the length of this altitude BD, the square of the length of the altitude BD square, is going to be the product of the segments AD into DC. So this segment and this segment. Now I am pretty sure that if you are able to somehow prove that ADC and BDC are similar, you can get to this value very quickly. But then the problem is that this thing, to prove this thing similar, is very difficult. For example, I'll tell you now, please pay attention to this video, watch this video in its entirety. You can watch it at 1.5x speed, but please look at this in its entirety if you want to go to the 99.5 plus percentile. Now, if you look at any standard reference material, for example, without taking the names of that institute, this is more or less what the institute will provide you. I will zoom in when required, but they will just give you the theories, and no doubt there is a lot of decent exemplar problems. There will be a lot of let's say practice problems and everything. But at the end of the day, the concept that I was looking at, the triangle on each side of the the triangle on each side of the altitude drawn from the vertex of a right angle triangle to the hypotenuse are similar to the original triangle and to each other. And then they have said that basically in the figure dB square is equals to AD square into DC. So they have just given the idea. Okay, so dB square is this, the height of the basically the altitude BD, that is equals to AD into DC, the product of the segments. Now one thing that they have done over here is that, just to make your life simple, they have introduced a fine lingo. So they said that the geometric mean, so basically the altitude from the vertex of the right angle triangle to the hypotenuse is the geometric mean of the segments into which the hypotenuse is divided. Now for somebody who can mug up formulas, who can remember these things, it becomes very easy for you to remember these things. But I'm telling you for a fact that in an exam condition, all these things, recalling all these things becomes very difficult. So what is it that you do? For some of you will say, sir, we have to go to the textbooks, the school days textbooks. I have that covered also over here. You can see this is an NCERT book from class 10th. Okay, so this is a class 10 NCERT book. You can get these PDFs, by the way, in the public domain. They are available everywhere. So I just wanted to show you that actually, if you go and this is a fantastic book, by the way. I have made some highlights here and there just to make sense. Okay, so if you go into the textbook, you invest your time only to realize that the exact question that I have asked you, that exact question they have also asked you in one of their exercises. Now what does that tell you? This should immediately tell you that this is in fact a very important question. Now obviously the triangle ADC, the smaller triangle ADC and the bigger triangle ABC, to prove these two triangles, the smaller triangle and the big triangle, it's much easier, because there is a 90-degree angle, the entire angle A, and this angle ACD is 90-degree, and there is a common angle D. So you have everything covered. The problem, however, is that when you consider these two smaller triangles, you don't know which other angle is equal. So if you don't know which other angle is equal, there becomes very difficult to, let's say, prove them similar. At the same time, when you don't know how to prove them similar, you can also not basically prove this property, which is AC square is equals to BC into DC, which is again, the length of the hypotenuse square is going to be the product of the segments. So DC into BC. Okay, now what is it that we can do at this point? Obviously the crux of this video is to, in a way or the other, persuade you to go the extra mile, do the extra efforts to prove this kind of thing. I am not in any ways trying to demean any material. These materials are fantastic, but again, what I am trying to tell you, basically where I am trying to take you, is that you have to go to the extra mile in order to prove that case. Okay, now let's come back to how we can prove it and how we can get to this formula. Right angle triangles are very important for your overall preparation, so you have to take this very seriously. Okay, so let's try to prove it now. So there are a couple of things that I need to do for us to prove that ADC is similar to BDC. Obviously I will not go the school days way. All you can see is that in triangle ADC and triangle BDC, you just give me two angles equal, and then every property will be there right in front of you. Obviously you can see ADC is 90 degree, so is angle BDC. So angle ADC is equal to angle BDC. This is 90 degree of course. So obviously in these two triangles I have one angle that is common. Okay, now see what I can do. You have to be able to go the extra mile. You have to be able to do this thing in your mind, right? So let's call this angle to be 1, this angle to be angle number 2, and let's call this angle to be 3. Which angle? So if I am allowed to, let's say, make some demarcations. So this is angle number 3, this is angle number 2, and this is angle number 1 and angle number 2, right? Now let me again take you back to what I was trying to tell you. If you realize in triangle BDC, guys, please understand, all this is for 99.5 plus percentile. Somebody who is saying, sir, I want to skip geometry, this video is not for you, you can skip the video. So in triangle BDC, what you can see is that this angle is already 90 degrees. So the other two angle, that is angle 1 plus angle 2, already obviously has to be 90 degree, because sum of all the three angles of a triangle is 90 degree. Okay, now there is a peculiarity happening at angle ABC that is already 90 degree. So can I say that angle 1 plus angle 3 is also equals to 90 degree? Because both of them, angle 1 plus angle 2 and angle 1 plus angle 3 is 90 degree. I can basically equate them, and you can see angle 1 and angle 1 can be basically cut out, and you will be left with angle 2 is equals to angle 3. Now the moment you are getting angle 2 equals to angle 3, you know that this angle is going to be equal to this angle. So that means this side will be in proportion to this side. Which side? AD and BD. Now you can apply the ideas of similarity, and I'm pretty sure you know the ideas of similarity. The sides opposite to the angles will be written in order, and you can get the value. Let's find that out also, for just for the sake of doing it. I have proved the two triangles to be similar. I have gotten two angles to be equal, and in a triangle, if two angles are equal, obviously the third angle has to be equal. Okay, now just because I need to prove that BD square is equal to AD into DC, let's write everything in order. Okay, so I know that these two triangles are similar. ADC is similar to BDC. Okay, I'm just writing these things to make my case easier, or my life easier, because I understand that you guys have totally understood the idea. Now this is going to be AB upon BC. So side opposite to 90 degree in ADC is this, side opposite to 90 degree in the BDC is BC. Now equal angles, side opposite to this is AD, side opposite to this one is BD, and the other angle is BD. For the ADC it is going to be BD, and for BDC the other angle is DC. Okay, now just pay attention to this much part. Okay, you can write this, cross multiplication will give you BD square is equals to AD into DC. Now the reason for me to showcase this thing, and obviously we have already proven it, and if you remember that this length or this segment BD, the altitude is the geometric mean of the segments AD and DC. If you remember this like that, that also helps you. But I'm telling you that all that, geometric mean and all that, you don't have to mug up. You can just do by, if your basics are in line, if you know what you're doing, nobody can beat you. Your 99 plus 0.5 plus percentile is secured. I'm telling you that there may be 3.6 lakh students appearing for the CAT. There is a lot of competition, but let me tell you, the type of competition, the level of students that you are going to be competing are not going to be doing all these things. So the only thing that again and again I'm repeating, please make the efforts. If you want to make the efforts, if you want to utilize this thing, you can join Trident classes, and the description will have all the links. You can come to me and we can have a chatter, and then we can possibly design classes. With that being said, this is me, Somajit Goswami, the Trident's CAT mentor, signing out.